All right, let's move on then. It's the final one over here in question 4. So if you have a scratch paper or notebook in front of you, let's give this a try yourself. See if you can follow this technique so you get a sense of it if it works for you or not. First, draw a diagram. So let me give you 20 seconds at most to go line by line and draw a diagram for this. And also write down the aim as well. So which variable are you solving equals question mark. The whole procedure in diagram and aim shouldn't take more than 30 seconds. So, okay, so hopefully you get an experience of this as well. How would I do it? This problem is slightly structured, not as traditionally. At first it goes at what depth? So it's asking immediately for the aim before even describing the situation. There's 2 options. You can write down the aim first, but I like to draw the diagram first. So I'll come back to this, right? So in the ocean, will a swimmer's eardrum rupture if a typical eardrum rupture? Okay, so you need to draw the situation where the swimmer's eardrum would just about not rupture, right? Just about the height, just about the depth that it's not ruptured. So you draw ocean, swimmer, and some depth. Okay, so let's call that H. Okay. And label everything. So look at your diagram if you have labeled things yet. So it's important in setting up the equation later, right? The reason why I can solve the equation so easily is because all the variables are set up to my advantage in the diagram. So experience a pressure at 1.8. Okay, so where is the pressure? Here, right? So the pressure here is 1.880 atm. Okay, so I'll just simplify the thing. I'll just write that. Okay, note that 1 atm, so the pressure here, maybe I should emphasize the pressure at the bottom. I might have a different pressure to compare with later. Note that 1 atm is 101 kPa. I remember that as well, but let's write that down. Okay, so 1 atm equals 1.0133 times 10 to the 5 pascals is SI units. It's good. Okay. The density of seawater 1025 kilograms meters. All of them is MKS units. All right, so I have everything here. So if your diagram, it doesn't have to be exactly the same as mine. If it's similar, congratulations. That's good. Right. So this is how my paper would look. And the aim is to find at what depth. Right. So all this in less than 20 seconds-ish should be achievable. Now you go ahead and you ask yourself, what are the relevant equations or definitions? My procedure is so repetitive, it's almost boring, but it works every time. That's a good thing about it. So what are relevant equations? So the only variable I'm really given is height and pressure. What kind of equations have that? So if just pressure, either you go with ideal gas laws, so you have a few that will come in mind, right? Pressure, you'll have PV equals to NKT. That's one, and then you have E is 3/2 PV or something like that. So, but these are ideal gas, right? So here it's clearly not about ideal gas; it's about fluids. So you should, if you are doing flashcard philosophy of studying, you should have one card for P related to ideal gas, and you should have another card related to fluids, right? Because for fluids, I can think of another 2 formulas relating P. Can you? Try to think about what will come up, right, in P for fluids. Well, for one, I would think about the hydrostatic equation, right? So it's P top. So it's relating the pressure on top and the bottom by rho GH. I always forget where does the top go, where does the bottom go. But you remember the bottom must have a higher pressure than the top. So which side should be higher pressure? This side, right? So the bottom should be the top, have a larger pressure. It's adding something. Okay? This is called a hydrostatic equation. A lot of people don't remember names. I think it's good because the other one, for example, is the Bernoulli equation. So that equals constant, Bernoulli, right? So which one is appropriate? Well, the first one, the hint is in the name. That's why I like knowing the name as well. So basically, if your fluid is static, you use the first one. If the fluid is moving, if the fluid is dynamic, let's just use this simpler word, moving. If the fluid is moving, use the second one. Hydrostatic equation treats static fluids. Bernoulli equation, fluid is moving. You see the V over here. There's a velocity. you can actually make a card for fluids. But all of fluids, really, there's only 3 equations. There's the continuity equation as well. So if you want to make some notes for your future studies, that's all good. It's also for moving fluids, right? So for moving fluids, you have 2 relevant equations. For static fluids, you have 1 relevant equation. In this case, this is static fluid. Immediately, there's only 1 choice. So it's P bottom equals to P top plus rho GH. And you see, we're not afraid of, a lot of us solving problems, we're not afraid of making extra labels on things. So label everything, like rho, what is rho? Rho of C, right? G and H is there. Good. So I see I have a new variable called P top over here. So this is P bottom. So where's P top? So let's label that as well. So P top should be here. So that is atmospheric pressure. Okay, so that's 1 atm. Okay. All right. Now we can go ahead. So that's my relevant equation. Okay, so this is hydrostatic equation. And the next step is, if you're confused, check off things that you know, right? All right, so let's do that exercise. I'll check that off. I know the bottom is 1.8, and the top is 1 atm. I know the C, I know G, and done. All right, so hopefully you see how straightforward things are. Let's plug in, since I have 1 more minute, let me plug in the numbers. Remember SI units, right? So this should be in, make sure you change this into a SI units, which is 1.8. Okay, so 1 atm is equal to 1.033 times 10 to the power of 5. So this is 1.8 times 1 atm. So just plug that in, right? So plug in, and atm is 1.033 times 10 to the power of 5 pascals. And that's just atmospheric pressure. 1.033 times 10 to the power of 5 pascals. All right, so that's my quick way of changing units. You don't have to do a lot of ratio and stuff. If 1 atm is equal to this, right, just take this and plug in to here, because this is 1.8 times 1 atm. So that's a pro tip for anyone who's already, if this is not confusing to you, you can try to use this more efficiently, right? So the bottom is 1.8 times 10 to 1.033 times 10 to the power of 5 equals to 1.033 times 10 to the power of 5 plus 1.1025, 9.81 times. All right, so that's good. So thank you very much. Hopefully these skills are useful.